All right, guys, here we go. So I want to do a quick review of what we talked about in the previous lesson with talking about continental drift again. What was the time frame for continental drift? You guys remember? No, be sarcastic. Seriously, what was our time frame? Well, like for continental drift with Alfred Wegener. No, it's a little bit longer than that. 1900, like early 1900s, right? So turn of the century. Plate tectonics comes around in 1967, so we're working our way there. All right, so we've got about 40 years here where we have continental drift existing solely as a proposed theory that, of course, is not widely accepted, right? And there's two major reasons why it wasn't accepted. You guys remember what those two reasons were? The two reasons why continental drift was not accepted. Alexis?
You didn't know how they moved and why.
There we go. So how and why. So how did the continents move and why were they actually moving? And so we have about this 40-year gap then from continental drift. And then, of course, some of you guys should know, which most of you guys probably don't know, is that during that 40-year gap between the turn of the century and 1945, we actually had two world wars taking place. So we had the First World War taking place during the 1915, and that in itself is kind of an interesting historical event. And we get some new technologies, and then after that, the United States emerges as a world power. We're kind of backwards up to then. And it's actually after World War I that we actually start having these technological advances in terms of our Army and our Navy. In fact, to the point where we decide to go show the world how strong we really are. And for those guys who have taken world history, that's the whole point of having the White Fleet that did a world tour, especially throughout the Pacific, visiting places like China and Japan, to flex America's muscle and to beg China to become an open door policy to trading. At that point, they were a closed door. They didn't want to trade with anybody but themselves. Okay. So that's World War I. And then we get into World War II, and then technology really starts taking off, and we get these really great technologies because of war. And I think that what happens a lot of times, we don't realize actually how much of the technology you guys have sitting in your hands actually starts as a War Department project. And it's really kind of amazing how far we've come and what we actually gain out of research that is done through the spectrum of war. And so I think it's really important for you guys to understand that. And so what we're going to find out is during World War II, we're actually doing our best to go around and try and find the evil Nazi subs and blow them out of the water. And it's because of that that we developed a couple of new pieces of technology that actually provide really, really good input that we didn't really know what to do with. Okay, so it's really kind of surprising outcomes. And so what I want to start us off with is what scientists thought the bottom of the oceans looked like. All right, you remember we talked about this before with geologic time, with these previous beliefs, these a priori notions, and these are really hard to displace. Okay, so when we have these beliefs that are really ingrained in our thought and our philosophies, it's really difficult to actually move them and put them aside and challenge them. So these beliefs have been around for quite a while. The first one, that the ocean was flat. It kind of makes sense. If you ever go down to the bottom of a lake, you'll notice that the lake bottom is completely flat. It's featureless. And it's also unchanging. Pretty much has been that way for millennia, and it'll continue to be that way for more millennia. It never changes, completely flat, it's boring. In fact, when you watch some of the videos, you guys ever watch The Blue Planet, and they do some of the deep ocean diving, it pretty much is that. It's basically the abyssal plain. It's really what it is. It's just a plain of nothingness. And we also assumed that the oceanic crust, for whatever reason, was older than the continental crust. Which kind of makes sense. As humans, we can see volcanoes erupting. We understand how that becomes new crust. So it makes sense that the ocean crust that doesn't seem to be ever changing. It definitely makes sense that would be older than the volcanic crust that we see on continents. So these are the big three things that we previously believed. And little bit by little bit throughout World War II, we get these pieces of scientific data that tell us we're wrong. And that's what today's lesson is going to be all about. Looking at each one of those technologies and how that helps us to realize what we know about oceans today. One of the first ones we have is sonar. Sonar is an acronym for sound, navigation, and ranging. Sound, navigation, and ranging. All right, so I want somebody to explain to me how sonar works. Go ahead, Tom.
It sends a signal,
Okay.
like sound, and it bounces off objects, comes back, and the computer determines the distance.
And how does it do that?
Streams of the signal.
Yeah, it's basically looking at the time that it takes, right? All right, so imagine my little boat up here, and it sends a signal to point A. It's going to take a lot longer to reach point A and come back to the ship, right? Very deep, so it's going to take longer. So therefore, the computer is able to then interpret that time that it takes. And then if my boat's directly over B, that's a much shorter distance to travel and come back. And so this is how we actually use sonar. We can actually figure out how far it is to go down. Now, why did we actually develop sonar? What were we trying to do? Yeah, we can detect the submarines. The submarines basically gliding underneath us. The sonar will pick that up and say, hey, you got a big object. And not only will it tell us that, but also will tell us how far it is under the water. So then you know at what depth the depth chart is. So you go roll off a bunch of barrels off the back end of a boat and hope for a big boom. So that's basically sonar, and that's what it was developed for. No other purpose than to go and find subs. That's it. That's exactly what it was designed to do. And it did that very well. But here's what we found out. After combing the ocean floors, we get map after map. All of a sudden, we started getting these weird images back as we started overlaying these maps, getting the pieces of the puzzle together. We started getting these really, really weird images. So let's actually zoom in here and take a look at this. What do you guys notice?
Looks like there's cracks.
It looks like there's cracks. Okay, good. What else?
Looks like various colors.
Looks like mountains. And what did you say, Bree?
Like the various colors.
You know, what do you think those colors represent?
Oh,
Yeah, the depth, right? So it's a false color. It's basically the colors represent like the altitude or the depth of that object. So you don't want to really go with the color, but you can use the colors to then make your observations. So, Bree, I think you said it perfectly. There's a bunch of cracks all the way down through here, right? And we have one really big crack going right down through here. Tom, you said mountains, right? We can see those right here. What do I have right here? Almost looks like a volcano, right? What was one of the previous believed facts about the ocean floor? What was one of them? One that we just completely blew out of the water.
The ocean floor is so flat.
Yeah, we used to think that the ocean is flat. This clearly shows us that the ocean is no longer flat. It's no longer featureless. We have tons of features. There's the same features on the ocean floor that we do on Earth's surface. The only difference is it's under 2 miles of water. That's it. So this is kind of a big one. So as scientists were looking at this data, like I said, it's not something that they originally were expecting to find. So this is actually kind of an accident that provides really good insight into how the Earth was made. So we stumble upon this information. Now, this is just a small piece. But when you put this into a worldwide view, we start to see a continuous mountain chain that extends around the entire globe. So now, we start asking ourselves some really good questions here. First of all, how did those mountain chains get in there? How did they create trenches that are 6 times as deep as the Grand Canyon? And some of these underwater mountains are taller than the Himalayas. So what forces are really contributing to create these features? Well, we still haven't got there yet. But yeah, this is another piece of that evidence where we're looking at it. And so these are questions that scientists are constantly asking themselves. What are we really looking at, and how do we actually make sense of what we're seeing? And they still have very limited information here. So all we really see is we have mountains. We still don't understand what's creating those mountains. All we know is that we have them. We have mountains, and we have trenches. And more importantly, on one side where you'd have a mountain, you'd have a trench running parallel on the opposite side. And that's a really important observation. So sonar was one of those big pieces of technology. The next piece of technology is called a magnetometer.